Hello everyone, welcome to Algebra Academy and our second lecture about partial fraction. What's meant by partial fraction? If I have these fractions 3 by x minus 1 plus 1 by x plus 2 and want to convert these fractions to single fraction. So just we do that. Take the common denominator. Okay, and the numerator here will be equal to plus 2 plus x minus 1. Okay, and here x minus 1, here x plus 2, and here 3x plus 6 plus here 1 x minus 2. That will be 4x plus 5 by x minus 1 x plus 2. Here we obtain this single fraction. So partial fraction process is the backward of this process. So I will give you this fraction and want to obtain these fractions. This is called partial fraction, and also this is called partial fraction of this single fraction. Okay, and if I have just clear that. Okay, if I have 4x plus 5 by x minus 1 plus x plus 2 will be equal to x minus 1 plus x plus 2. And here, I don't know here what to write here. Okay, and so let's assume constant b and a. Okay, so now how to find these constants? A, b. We have three methods to calculate a and b. The first is by comparison method. Here, to find a and b, we will able to compare the coefficient of x, x squared, cubic x. Okay, so here to find that, the first step in comparison method is to multiply into the common denominator. Okay, here the common is x minus 1 x plus 2 into both sides. So here equal to a x plus 2 plus b x minus 1. Here I will start to compare from the highest power of x in both sides. Here the highest power is x power 1. Okay, so here 4 will be equal to a from here, a into x plus b, and here is first equation to get a and b. Again compare, here let's write here x power 1, x power 0, the free term here 5 equal to here 2a minus b here, and here is second equation. By simple way, just add 1 to 2. Okay, so here I will obtain 9 equal to 3a. So a equal to 3, and from any one of these I will obtain b equal to 1. Okay, so this is the first method to find a and b by comparison method. Okay, let's move to second method. Here we have substitution method. Here is first step is the same as in comparison method, to multiply into the common denominator. Okay, minus 1 plus 2 in both sides. Okay, so we will get that equal to a x plus 2 plus b x minus 1. Here in the substitution method, to get the constant a, we will substitute by the 0 which related to this constant, zeros of the denominator. Here the zeros of this fraction is equal to 1. So to get a, we will substitute by x equal to 1. Okay, so let's do that. For 1 plus 5 equal to a 1 plus 2 plus, here if we substitute by 1, this will be eliminated, and here 0, here 9 equal to 3a, so a equal to 3. The same as b, here to get a, we will substitute by the 0 of this denominator. Here x equal to negative 2, x equal to negative 2. Here 4, 2 plus 5 equal to, here this will be eliminated. Okay, b, here we will obtain that this will be equal to 3b, so b equal to 1, the same as in comparison method. Okay, so let's move to the second third sorry method to get constants. Okay, here is direct method. Here we here we are not able to multiply by the common denominator. Here, let's just rewrite that for x plus 5 by x minus 1 by x plus 2 equal to a by x minus 1 plus b by x plus 2. Here, to get a, just look at this side, okay, and hide the denominator in the fraction related to a. Here we will hide that, okay, and substitute by the 0 of this fraction. So x equal to 1. To get a equal to 4 by 1 plus 5 by here 1 plus 2 will be 3. Okay, and same thing b, we will hide this expression or this factor in the denominator, okay, and substitute by 0 of this fraction, x equal to negative 2, okay, so b will be equal to 4 into plus 5 by minus 1, so b here will be equal to 1 to obtain the constant in the partial fraction, okay. Now let me write that if I have this function equal to b of x q of x. Now b and q are polynomial equation, okay. B of x q of x are both polynomial with the positive power of x in all terms, okay. So here we use the direct method to get the constant of the partial fraction of these functions, but there is some limitation of using direct method. Here, limitation of using direct method. We only use direct method in these two cases. Okay, case one, if I have different linear factors of function q of x of the denominator. Okay, or if I have repeat linear factors of q of x. But here we use direct method only to obtain the highest power factor constant. And that will be clear by example. Okay, now and to obtain the partial fraction of this function f of x, there is a sequence of steps to make that. Okay, so steps of solution. First step is to check if f of x is proper or improper here, and f of x is called proper f. So proper f degree of v of x is less than degree of u of x, and improper f degree of is greater than or equal degree of u of x. And if f of x is proper, we will move forward to the next step here. And if is improper, sorry, we will go to long division to convert f of x from improper function to proper function. Okay, and next step here is to factorize u of x. Okay, so next step is factorization of u of x into linear factors or irreducible quadratic factor. Okay, and third step here is to assume the constant. And fourth, to find the constant by the three methods we talked about before. Okay, okay. Just write this here to follow the steps of solution and move to our four cases here of factors. And let's start with case one, different linear factor. If I have that f of x equal to 5x by x squared x, and let's follow these steps. Okay, so step one, to check if f of x is proper or improper. Here we have degree, first degree of x, here second. So our function here is proper. So let's move to step 2. Factorize q of x. Here we have q of x equal to x squared 3x 2. Here factors of this function are x1 x minus 2. Okay, so step 3, let's just rewrite our function after factorization. So 5x by x minus 1 x minus 2 equal to x minus 1 plus x minus 2, and here in our third step to assume our constant, here a, here b. Last step here to find a and b. Let's check that limitation of using direct method. We have here different linear factors, so we can here use direct method. If we use direct method, as we said before, just to obtain a, just hide x minus 1 from here and substitute by x equal to 1 the zero of this fraction. Okay, so a equal to 5 1 5, just hide x minus 1, and here we have x minus 2, and here x equal to 1. So here a equal to negative 5, and b, if we make the same thing as a, just hide this factor which related to the fraction contained b, okay, and substitute with x equal to 2. So let's make them. Here 5 2 by, just hide that. So we have here x minus 1 and x here equal to 2. So we have here b equal to 10. Okay, I hope that's clear. Just clear that. Okay, and take our next result. Okay, here write that. Okay, just if we have 12 by x x minus 1 x minus 2. Let's follow our steps. Step 1, prover or improve. Here we have a free term, so we have x power 0, 0 degree, and here we have third degree. So we have proper function. Step 2, to factorize q of x. Here q of x is factorized. Okay, so let's move to third step. Just rewrite x, x minus 1, x minus 2 equal to x, x minus 1 and x minus 2. Here we have to assume our constants. So here A, B, C, step 4, find constants. Here let's check the limitation of direct method. We have here different linear factors of q of x, so we can use direct method. If we use direct method here, A will be equal to just hide x from here and substitute with 0, which is the 0 of this fraction. Okay, so we can get x minus 1, x, x here equal to 0, so A equal to 6. Okay, B equal to by just hide x minus 1 from here. So we have here x minus 2 and substitute with x equal to 1 is the 0 of this fraction. So if I substitute with x equal to 1 here, b will be negative 12. C 12 by same thing, just hide x minus 2 from here and substitute with x equal to 2 is the 0 of this fraction here. So C will be equal to, okay. Another example of first case here is if I have equal to cubic x minus 2x by x squared plus 3x plus 2. Let's follow our steps. So step 1, let's check if proper or improper. Proper, improper. Here we have third degree and here second. So we have here function improper function. So let's move to long, okay, long division. Okay, here we have x cubic x minus 2x, and here the coefficient of x squared is 0, so 2x, and here x squared plus 3x plus 2 here. That the cause of using long division to convert the improper function to proper function. Okay, so here by dividing cubic x by x squared we get here x, okay, and just multiply x into the quotient function, okay, here cubic x plus 3 x squared plus 2x, and then subtract between this from this. Here we have 0 minus 3x squared minus 4x. here we have second degree, and here we have second degree also, so it continue in long division. Here if I divide 3x squared by x squared, here the result, and multiply negative 3 by the quotient, here we have 3x squared, here 9x, here 6. Okay, subtract this from this, so here we get 0, 5x plus 6. So let's rewrite that. So x cubic x to x by x squared plus 3x plus 2x plus our reminder here 5x plus 6 by the quotient function plus 3x plus 2, and now we deal with this fraction here. Okay, we convert the improper fraction here to proper fraction, this with here first degree and here second. Okay, and now let's deal with this term. Okay, just clear with that. Okay, so here we have this will be equal to x plus 5x plus 6 by x squared plus 3x plus 2. Now step 2, we now deal with this fraction. Okay, and now step 2, factorize q of x. Q of x here equal to x squared plus 3x plus 2 will be equal to x plus 1, x plus 2. So rewrite this for step 3. Okay, we have f of x equal to x 3 plus, here we have x plus 1, and here x plus 2. Here we have a and b for the assumption of our constant. Okay, and here let's move to step 4 to get a and b by direct method. Okay, if we use direct method, we will just, as we said before, we will hide this term. Okay, from here and substitute with -1, and here we will hide x plus 2 and substitute with -2. So a here will be equal to 1 and b equal to 4. Okay, here's that and move to our, okay, so the next example here is f of x equal to 9x plus 11x minus 2 by here x minus 1 by square root of x plus 2. So here we don't have polynomial equation neither in the numerator nor the denominator. So just we will replace y, we will make y equal to square root of x. So we write that for f of y equal to y squared plus y minus 2 by y squared minus 1 and here y plus 2. So here we deal with f of y and don't forget that y equal to square root of x. Okay, so step 1 for this function proper or improper. Here we have second degree, okay, and here we have third, so we have a proper function, okay, and let's move to step 2, factorize q of x, okay, so q of x equal to y square minus 1 y plus 2, so that will be y minus 1 y plus 1 for expanding this bracket and here y plus 2. So here rewrite that we have here f y equal to y square plus 11y minus 2 y y minus 1 y plus 1 here y plus 2 equal to just for the third step here we assume that our constant here 1 y plus 1 here y plus 2 here a b c. So here by direct method for step 4 here is step 3 from here find a equal to b equal to c equal to, so for a we just hide y minus 1 from here using direct method as we have here different linear factors of the quotient factor. Okay, so just hide y minus 1 from here and substitute with y equal to 1 as this is the zero of this fraction. Okay, so just 9 square plus 1 minus 2 by we will hide that, so we have here y plus 1 here and y here equal to 1, so a here equal to 3 and the same thing with b and c, so b will be equal to 2 and c equal to 4 by using direct method. Okay, I hope the first case here now clear. Okay, and let's move forward to the next case. Okay, here. Okay, if we have a repeated linear factor, so f of x equal to x squared minus 2x plus 4 by x plus 1, and the words is bracket is power 3. Okay, so what should we do? Okay, now just follow the steps as we said before. Okay, so step 1 is to check if proper or improper. Here we have second degree and here we have third. So we have here proper. The second step here is to factorize u of x, and here q of x is just a repeated linear factor, so q of x is factorized. Okay, so let's move to step 3. Step 3 here to assume constant. Okay, so let's rewrite that x squared minus 2x plus 4 by x plus 1 power 3, that will be equal to, in this case, in the repeated linear factors, we write our factors in descending way, start from the highest power, so just like that, x plus 1 power 3, x plus 1 power 2, and just x plus 1. Okay, and here a, b, and c. Okay, this is only the difference between the last case of the different linear factor. We have here repeated linear factors, so just write these factors in a descending way, start from the highest power and to the first power. Okay, just here rewrite that. Okay, now f of x squared minus x plus 4 by x plus 1 power 3, so x plus 1 plus x plus 2 here, 1 sorry, plus x plus 1 here, a, b, and c. Okay, so let's check if we can obtain any of these constants by direct method. We have here, we don't have here different linear factors, we have here repeated linear factors. So we can only obtain the constant a by the direct method. Okay, the highest power of the repeated linear factor. Okay, to get a by so using direct method, a will be equal to just hide this denominator from here. Okay, and substitute with zeros of this bracket, so x equal to -1. So here we have square 1 plus 4. So a here equal to 7. Okay. Now we have this. Just rewrite that here equal to 7 by x plus 1 plus b by x plus 1 plus c by x plus 1. Here we can't find b or c by direct method, so we will use the comparison method. Okay, here using comparison method, and the first step is to multiply by the common denominator, so multiply by x plus 1 and this cube. Okay, just here that and start to find b and c by comparison method. Okay, now write that by multiply the common denominator. Okay, we obtain the 2x plus 4 equal to 7. Okay, plus b into x plus 1 plus c x plus 1 square. Okay, now compare, start from the highest power here or here, compare the coefficient of x square. Okay, so we have here 1 equal to c, c equal to 1. Okay, and again compare coefficient of x. Here we have 2 equal to b plus, and here if we expand this bracket we have x squared plus 2x plus 1. Okay, here we have 2c, so b here equal to -4. Okay, okay, let's move to another example here. F of x equal to 6x plus 1 by cubic x 2x minus 1. So here we have combined the case between case 1 and case 2 of linear repeated factor and different linear factor. Okay, so let's start from first step. So step 1, let's divide it here. Okay, step 1, proper or improper. We have here first degree and here fourth. So we have a proper function. Step 2, we have here a repeated linear factor and the different factor, single different factor. So q of x is factorized. 3 here. Just rewrite that in this form: x plus x squared plus x plus 2x minus 1. Just we have here repeated linear. Start from the highest power and in ascending way write the factor down to the first degree. Okay, and here we have A, B, C, and D. Okay, step 4: to find A, B, C, and D, let's check the limitation of using direct method. We have here different linear factor here, so we can find D by direct method. Okay, and we have here a repeated linear factor, so we only can find A by direct method. Okay, so using direct method we can find A equal to and D equal to E here. Just hide this factor from here and substitute with the zero of this fraction. Zero of this fraction is x equal to 0. So let's do that. So we have here 1 by negative 1. So A equal to negative 1. Okay. And D here, just hide this factor from here and substitute with half. Okay, so here we have D equal to z, okay, plus 1 by square. Okay, so here we have D equal to 32. Okay, okay, and for B and C we can use substitution method or comparison method to find B and C. Okay, so just clear that. So using comparison method to find B and C. So the first step is to multiply by the common denominator here, multiply by cubic x by, okay, so we get plus 1 equal to, we have A equal to negative 1, so just write it 2x minus 1 plus B by x by x plus C x squared by 2x plus we have D equal to 32, so just write that. Okay, so here compare, start from the highest power, so start with cubic x. Okay, so 0 equal to, here we have 2c, okay, plus 32 So c equal to negative 16, and compare coefficient x squared. We have here 0 equal to 2b. If we multiply this here, we have 2, we have c, okay, negative c here. So just b will be equal to negative 8. Okay, and as we say, negative 1 day 32. Okay, here is an example of a combined case between the first case and second case. Okay, just let's move forward to our third case here. Okay, just okay. Our third case, if we have an irreducible quadratic factor. Okay, so just let's write this example. So if x equal to say x plus 5, x squared plus 1, x squared plus 4. Here in these two brackets, the roots are imaginary numbers. Okay, so this are irreducible quadratic factor. What should we do? Okay, just start from the first step here. Just step 1, just proper or improper. We have here first, and here we have fourth degree. So we have proper function f of x. Okay, step 2, we have here a reducible quadratic factor. So q of x just factorize. Okay, step 3 here, just rewrite our function here, x squared plus 1 by x squared plus 4 equal to x squared plus 1 here, x squared plus 4, and here we assume two constant for each fraction. Okay, because we have here second degree. Okay, so here ax plus b, and here cx plus d. Okay, let's move to step 4. Here we can use the direct method, as we don't have here different linear factors or a repeated linear factor. Okay, so here using comparison method, for get a, b, c, and d. Okay, so let's do that. The first step, as we said in the comparison method, is to multiply by the common denominator here by x squared plus 1, x squared plus 4. So we have that plus 3 equal to ax plus b into x squared plus 4, and here plus cx plus d into x squared plus 1. Just compare from start from the highest power. Here we have power of 3. Okay, so compare coefficient of cubic x in both sides. Okay, here we have in the left side 0 equal to, here we have a plus c. So c equal to negative a. And here same thing, x squared 0 equal to b plus d. So d will be equal to negative b. Okay, just continue. X we have here set equal to 4a plus c. So if I replace that by negative a, so a here equal to 3. Sorry, a here will be equal to 6 by 3. So a here equal to 2 and c will be equal to negative 2. Okay, just continue. X for 0, the free factor, the free term here. So 3 equal to, here for b plus d. Just replace this by negative b. So b will be equal to 1 and d equal to negative 1. So the difference here in this case, the third case, different irreducible quadratic factor, just for each fraction we will put two constants. Okay, as we have here an irreducible quadratic factor. Okay, okay, so move to another example here. If we have 3x minus 6 by x cubic x minus 1. Okay, so start from first step. Here we have here first, here we have third. So we have forward fraction. Second step is factorize q of x. So q of x here equal to cubic x minus 1. So we can factorize this by x minus 1 by just that second bracket here, x squared plus x plus 1. Okay, the third step here, step 3, we have here just rewrite that. Okay, 3x minus 6 by cubic x by equal to, here we have here linear factor, and we have here an irreducible quadratic factor. So x squared plus x plus 1 is an irreducible factor. Okay, so here we assume here a constant and here two constants. So we have here bx plus c. Okay, okay. So here we have 3x x by x cubic x equal to a by x minus 1 plus b x plus b by x squared plus x plus 1. So just we have a combined case between the first case and the third case. Okay, here we can find a by using direct method as we have linear factor. Okay, so just by linear by direct method here, a equal to, just hide this from here and substitute with x equal to 1. So we have here 3, 1, 6 by, here we have square this bracket plus 1 plus 1. So a here will be equal to -1. Okay, and for b and c we use comparison method. Okay, and just multiply by the common denominator here. So we have here 3x minus 6 equal to, just here, negative. We have here a equal to -1. So we just write that square plus x plus 1 plus bx c into x minus 1. Start from the highest power. Here we have here the highest power is the second power. So compare coefficient of x squared. So just here we have 0 equal to -1 plus -1 plus c negative b. Here we have, just sorry for this. Okay, we have here 0 equal to -1 plus b. So b equal to 1, and by comparing the coefficient of x we have c equal to 5. Okay, just clear that and move to the last case here of partial fraction. So just clear all of that. Okay, and get that here. If we have this example here, f of x equal to x squared plus 2x plus 5 by 2x squared plus 6x plus 7 squared. So we have here a reducible quadratic factor here. So first step to check if proper or improper we have here second, and here we have fourth. So proper. Step 2, we have here q of x is a reducible quadratic factor, so q of x is factorized. Okay, move to step 3, just assume our constant here, so just rewrite that x squared plus 2x plus 5 by 2x squared plus 6x plus 7 squared will be as that. Just start from as you said before, start from the highest power here and in a descending way up to first power. Okay, so just x squared plus 6x plus 7 squared. Okay, and here 2x squared plus 6x plus 7. Okay, and here we assume for each of these factors two constants. Okay, so we have here ax plus b, and we have here cx plus d. So step 4, we have to use substitution method or comparison method. Okay, just we will compare the coefficient of x. Okay, start from the highest power. Okay, and we will obtain that a will be equal to 1, b will be equal to 1 half 1.5. Okay, and c equal to 0, d equal to half. I hope this lecture is clear about these four cases here, which we discussed later. We have here four cases. Okay, just for any function. Okay, or for any fraction function. Okay, follow just follow these steps for check the function if proper or improper, for factorization of q of x, for assumption of constant, and for finding constant by direct method or by substitution method or by comparison method. And don't forget the limitation of using direct method. I hope all of that clear, and thank you.